And welcome back, and it is the 24th of March, higher plus 5 a day, and let's just go to the first one. Right, factorise completely. Now, this is not absolutely true, but the word completely or fully tends to indicate you can do a couple of things here. So just be very careful that you can factorise everything you can do. So I would suggest that everyone would notice I can factorise an x out, which is going to be x times 100 minus x squared. The difficult bit is you then need to spot your difference of two squares. So that's going to be 10 minus x, 10 plus x. And that is one of those things you need to learn and you need to be on the lookout for. It's very easy to miss, but you do need to be aware of it. Next question. Right, so the next question says I've got the universal set, so that's all numbers from 2, sorry, all even numbers from 2, so it's 2, 4, blah, 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 all the way up to 400. By the way, in your set notation, do not do the triple dots. That's bad. You have to write the elements out, but that's just so I can remember. And then it says O is a set of odd numbers. Okay, well, there's none of those. What does it want to do, first of all? Find out how many numbers are in OP. Okay, so basically what's the total of numbers that we've got here? This is not as bad as it looks. So how many odd even numbers are there? Well, there's 0. How many even prime numbers are there? There's 1, and that's the number 2. Okay, for the cube and square numbers, I think I'm just going to write them out, aren't I? Let's basically work out the square of all the even numbers until I run out. So I'm just going to write the numbers down here just so I don't make a silly mistake and miss one out. So 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. And actually, you know what? I don't need to write them out, do I? Because I know all of these are squared and they square for 400 or the other. So that's going to be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So there are 10 square numbers. In fact, I'm going to write that here. Cube numbers, so again, I'm going to basically run through this. So 2 cubed is 8, 4 cubed is 64, 6 cubed is 216, 8 cubed is 512, and that is too high. So there are 3 of those, but there's not, is there? Because there's 2 of those. Why are there only 2 of those? Because I've already counted this one in my square number. So I've already used 8 squared is 64, so I'll be double counting. So therefore, add these up, there are 13 numbers overall. That I've seen that sort of question before in a, I don't know, it was an IMC or an SMC or a number theory question. Just be very aware of that because a 6 cubed, or when you start cubing and squaring, some of the numbers do overlap. That's a really quite difficult question. It's one of these questions I suspect in a real GCSE, 3 marks, of which the final mark is for spotting the pairing up. Either way, 13 is your answer. Final question, actually no, it's not final question, 2 more questions today, 3 more questions today, nowhere near final. The area of an ellipse, width A and height B is given by, find the shaded area. Well, this one's not too bad. So I'm just going to do the area of the rectangle, which is 12 times 7. And then I'm going to take away the area of the ellipse, where it gives me the formula. So that's going to be pi times 12 times 7, and divide all that by 4. And pull this together, so 12 times 7 is going to give me 84. And then 12 divided by 4 is 3, and 3 times 7 is 21, so that's 21 pi. Now it doesn't say exact value, so I'm also going to get my calculator out quickly and work that out. So 84 minus 21 pi gives me 18.0 centimetres squared. Not as bad, the question above was definitely a bit worse. Next question. A solid is made by putting a hemisphere on top of a cone. Find an expression. So, i.e. not an equation, but I don't think that'd be that funny. For the volume. So my volume is equal to the hemisphere. Well, before I do that, first thing I always do is what is the radius? Because I need that. So the radius, write it down here, radius is 2x. So the volume of the hemisphere, let's not squeeze this in, is going to be a half of 4/3 times pi times a radius cubed. And the volume of the cone is going to be 1/3 times pi times a radius squared, so 2x squared, times 10x minus the 2x of the radius, which is 8x, so times 8x. And then very carefully, let's try and tidy this up. So I've got a half times 4/3, which is 2/3, times by 2 cubed, which is 8. So actually, let's, exactly case in point, let's not mess this up by doing it carefully. So a half times 4/3 is 2/3 times 8 times pi times x cubed. And then I'm adding on 1/3 times 4 times 8, which is 32, pi x cubed. And let's pull all this together. So 2 over 8 is 16 over 3. So 16 over 3 pi x cubed plus 32 over 3 pi x cubed, or 16 and 32 is 48. 48 divided by 3 is 16. So that's just going to be 16 pi x cubed. Good question, that. That's a very reasonable, sort of difficult end of, not very end of paper, but sort of endish of paper question, but good question. Final question. Now, this actually is the final question. Final question of today. The coefficient of the x squared in the expansion of this thing here is 9. Find a. Now, normally here you get x cubed and you just multiply the x's together, or you might get the coefficient and you multiply these numbers together. You don't get that here. So I'm actually going to have to expand it. So let's do that. So x plus a times x plus 3 is going to be x squared plus 3 plus ax plus a times 3, which is 3a. And I'm multiplying all of that by 2x minus 3. Now, at this stage, we can be clever. Because what do I need to do to get an x squared? Remember, I want an x squared. Well, I'm going to multiply that by the constant, which is going to give me minus 3x squared. And then I'm going to multiply this one here by the x, because that will give me an x squared. So I'm going to add on 2 lots of 3 plus ax. And that's going to give me x squared. And that's going to give me 9x squared. This is a good question. Now, let's forget the x squares, don't need those. So that implies that minus 3 plus 6 plus 2a, expanding the bracket, is equal to 9. Minus 3 plus 6 is 3, so 3 plus 2a is equal to 9. Take away 3 is 6, divide by 2, which means that a is going to be equal to 3. Wow, the last couple of days have got notably harder, or at least a couple of notably harder questions. Really enjoy those 2 days. Do, as ever, like and subscribe. Let me know how you did. That jump in difficulty, I think it might continue. I have done a few of these in the past when I've been teaching, but I do know these get much harder as I go through the year. As I say, let me know how you've done. Like, subscribe. See you tomorrow. Thanks all.